So yesterday we learned about the rational root theorem, and then we did some practice when the lead coefficient of the polynomial is 1. Today we're going to look at it when the lead coefficient of the polynomial is not 1. So our first example is to find all real zeros of f of x equals 10x to the fourth minus 11x cubed minus 42x squared plus 7x plus 12. So the first question is, how many possible real zeros could I have? What's the maximum number? Yes, 4. Because it's a degree 4, can't have more than 4 real zeros. Now the next issue we have to address is, if we have rational zeros, what form must they be in? So we're going to be looking for factors of some number over factors of another number. What are what factors are going to be in the numerator? Ingrid? Factors of 12. We're pulling from our constant term. And the denominator? Tori? 10. Pulling from our lead coefficient. Christian, what are the factors of 12? There we go. Sarah, how about factors of 10? What's that? 5 is 1. 2. And what's the last? 10. Sometimes it's easy to forget the most obvious one. Alright, so if we set up our ratios and simplify, which you guys had lots of practice with yesterday, we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Then we have 2 over 1. That's already listed, because that's 2. 2 over 2 is already listed because it's a 1. Then we have 2 over 5, and 2 over 10, which reduces to 1/5. Then we have 3 over 1, also already listed. 3 over 2, 3 over 5, and 3 over 10. Then we have 4 over 1, also already listed. 4 over 2 is listed. 4/5, and 4/10 reduces to 2/5, so that's already listed. We have 6 over 1, which is already listed. 6 over 2 is already listed. 6 over 5, and 6 over 10 is 3/5, which is already listed. Then we got 12 over 1, which is covered. 12 over 2 is 6, which is already covered. 12 over 3 is 4, which is already, or 12 over 5 is the next one. And 12 over 10 is 6/5, which is already covered. So those are all of our possible zeros. Right there. Only 28 possibilities. That's good. Not too bad. So Ethan, how do we find a real zero? What do we do? Start putting them into synthetic substitution. So we rewrite our coefficients of our polynomial, which are 10, negative 11, negative 42, 7, and 12. Oops, let's straighten that out a little bit. And we start checking some of those numbers. So out of that list, Lily, which one do you want to check first? 2. Let's see if they'd make it that obvious. All right, Nate, what's our first number? Sarah? Add. 9. Antonio? Ingrid? Did you say 24? Negative 24. Tori? Christian? In the wrong direction, because that's a positive 7. Nope. Negative 41. Sarah? Sometimes these numbers get really big. Whoa. Nope, we're multiplying this by 2.
Oh, okay.
And the last one, Ethan. Yeah, the really important part is that the last one's not 0. Okay, because since it's not 0, that means 2 is not a solution. Now here's the really cool part. Not only is 2 not a solution for that polynomial, it's not going to be a solution ever. So even when I break it down to smaller polynomials, I know that 2 isn't going to work in any of the parts. So that's out of the running forever. Bye 2. Alright, Ethan, what number do you want to try next? Oh, sorry, I'll leave that list up there. Negative 3. Everybody's afraid of the fractions. Alright, Lily, what's our first number? Nate? Sarah? Positive something. I'm positive it's something. 123. Antonio? Come on. Come on. Ingrid? Tori? You guys are out of practice.
Negative 230.
That number.
6.
Christian? 708. Sarah? Not 0. So, way to go, Ethan. Yours was even further off than Lily's. Not negative 3. It will never be negative 3 for this polynomial. Alright, so out of 28 choices, we have now eliminated 2.
Making progress.
Alright. Lily. One fifth. Alright. 1/5. Alright, Nate, what's the first number? You got the easy one. 2. Sarah. Antonio.
9/5.
Negative 9/5. Ingrid. Let's see, 42 over 5 is 210 over 5, right? So we got negative 219 over 5. Right now it's negative 9 over 5. And when we add negative 42, which is negative 210 fifths, we get negative 219 over 5. And then a fifth of that, which is actually the easy one, because all you have to do is multiply the denominator by 5. What do we get, Tori? Multiply the denominator, bottom number, by 5. What's 5 times 5, Tori?
I can't think. 25.
Alright, and the
25.
top stays the same. And Christian. So 7 25ths, or 7 with a denominator of 25. Yeah, it's 175. Lily's going to get jumped after class. 175 minus 219 is negative 44. Ooh, coming back down. And a fifth of that. What are we getting when you multiply the denominator by 5, Sarah? Can we just agree that that is not the same as 12? Everybody okay with that? All right.
Why is this a thing?
Could have some way to approach it, right? All right, so we can eliminate positive 1/5. Let's not let Lily choose again. Nate, I think it's your turn to pick. Negative 1. All right. Sarah. Antonio. Ingrid. Tori. Christian. Sarah. Ethan? Okay, not going to be 0, right? So now negative 1. Alright, how about I skip to the end a little bit? How about I pick 1? Because we know it's not negative 1. We've eliminated like 4 out of 28. Let's try negative, I like fractions, 1/2. Alright, Lily, what's negative 1/2 times 10? Okay. Nate? Sarah? Yeah, 8. Antonio? Sarah? Ingrid? Tori? Christian? 0! We found one! X equals negative 1/2 is a solution. Isn't that exciting? Now here's where it gets better. You ready? So that leaves us, that takes out the factor x plus 1/2. And we know it leaves us with 10x cubed minus 16x squared minus 34x plus 24. Now, if you'll notice that cubic polynomial, every coefficient is divisible by 2, so we can factor out a 2. And we're left with 5x cubed minus 16x squared minus 34. Forgot to take out some numbers there. Minus 8x squared minus 17x plus 12. Tell you what, I'll leave that on the video so you can go back and look at my mistake again. And Mr. Larkin made a mistake. Happens all the time. Alright, we found 1 0. That means there's possibly 3 more, right? That's the bad news. The good news is, if we go back to this list, we've already eliminated some of the options. Now here's the thing. Just because we found that negative 1/2 was a solution doesn't mean it's not going to be a solution again. It can appear twice, because you could have a factor that comes out twice. So we don't want to eliminate that, but you'll notice that our our constant term is now 12, our lead coefficient is now 5. So anything that had a denominator of 10 can also be eliminated. Because the factors of this new cubic polynomial here, the solutions have to have factors of 12 over factors of 5, not factors of 10. So that means we can eliminate this one here, and I think that's it. Probably another one though. Let's see. 1/5, 2/5, we got those. Oh wait, no, we can eliminate anything with a denominator of 2, because 2 doesn't go into 5. So that comes out too. Everybody good? Well, good or not, let's go. Let's find the next one. We've already decided we're not letting Lily guess, right? So let's pick on Sarah this time. Let's go with Sarah Smith. I might have just like revealed your identity to the whole YouTube world, but if they can figure out which Sarah Smith it is, more power to them.
Okay,
6. Let's try 6. All right, Ethan, what's our first number?
30.
Lily? Sarah? Oh, sorry, I skipped Nate.
130.
Did you say 113?
No.
132. Okay. Sarah? Antonio?
$690.
690. Not going to be 0, right?
No.
All right. As much as I like pitting you all against each other and seeing who's just awful at guessing, this is running a little long, so let's take. We know 6 is not in there. Let's try. Let's try 3/5, because everybody loves fractions. Ingrid, first number. Yeah. Three. Tori? Christian? Sarah? Ethan? Lily? 0. Yay, 3/5 works. Who'd have guessed? Now, just to point out, that means that 3/5 would have worked on this one too. A little late, but 3/5 also would have worked back there. If it works at the end, it's going to work back there. So now, we have taken out 2, x plus 1/2, x minus 3/5, and we're left with 5x squared minus 5x minus 20. And you see that you can factor a 5 out of that quadratic. So we've got a 5 times a 2 at the front. Leaving us with x squared minus x minus 4. Now we should be able to look at that quadratic and determine whether or not we can factor it. Are there factors of -4 that add up to -1? What factors of -4 add up to -1? Oh, you were nodding, so I thought you knew what they were.
So I was talking to myself in my head.
Oh, you were talking to yourself in your head. Okay. Glad that you nodded in response to yourself. It's good. It's good to carry on a little conversation privately. Are there factors of -4 that add up to -1? No. So how else could we solve that to find the real zeros? What other method? Yeah. Quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So you guys know how to plug those in, right? You got 1 plus or minus, you find you get the square root of 17 over 2. So there's two real solutions there. When you simplify the whole quadratic formula, that's what you're going to get. And we also already found -1/2 and +3/5. There's our real zeros. Any questions? I won't ask if you're all good with that because you're all looking ahead to your homework and realizing that you're not good with that, but that's the way life is. Questions? Okay, let's look at example 4 real quick. Some ice sculptures are made by filling a mold with water and then freezing it. You are making such an ice sculpture for a school dance, not this school. It is to be shaped like a pyramid with a height that is 1 foot greater than the length of each side of its square base. The volume of the ice sculpture is 4 cubic feet. What are the dimensions of the mold? So we have 3 dimensions for this pyramid shape. You've got a base that's x by x and a height that's x plus 1. So if it were a prism, that would be our volume. If it were a solid rectangular prism, it would be length times width times height. Since it's a pyramid, remember that the volume is 1/3 of that. So we have to multiply that by 1/3. And they tell us that the final volume of that pyramid is 4. We need to solve this polynomial to find what value of x would work. Now, how can we get rid of that fraction? How can I eliminate that 1/3? Make it a little easier to deal with. Yeah. Multiply both sides by 3. So that leaves us with x times x plus 1 equals 12. And if we distribute on the left, we get x cubed plus x squared equals 12. So we want to solve the polynomial x cubed plus x squared minus 12 equals 0. Now, as we've been covering, we're looking for factors of 12 over factors of 1. Right? So that just means we're going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. That's still a lot of possibilities. There's 12 possibilities there, but I can eliminate half of them right away with a little bit of common sense. What could I get rid of? Why? Length, right? X represents the lengths of the sides of the base. You can't have a negative length for your pyramid. So we can get rid of all the negatives. That already narrows it down to only 6 possibilities, which is a lot better than what we've been dealing with so far today. The other thing we can do, as we're setting it up, 1, 1, -12, am I missing something? Okay, the correct answer is yes, I'm missing something. I'm just waiting for you to spot it. Sarah? I need a 0 to take the place of my missing x term. The other thing I can do is I can think that if the volume is 4, then a side length of 12 seems a little bit excessive. 12 is probably not a good place to start guessing. Ingrid, what do you think a good place to start guessing might be? 2. Okay, Tori, what's my number that's going red here? 2. Christian. Those are both positive numbers. I'm adding here. Sarah? Ethan?
6.
Lily?
12.
Nate? 0. Hey, we found a solution already. X equals 2. Ingrid's either really good at guessing or looked ahead in the book and cheated. Let's just pretend she's really good at guessing today. Is that okay?
Yeah.
Okay. Now we could check and see. We're left with x squared plus 3x plus 6. Those are our remaining coefficients. Is that factorable? Are there factors of 6 that add up to 3? No. We could do a quick check on the quadratic formula to see if there's other solutions. We get negative 3 plus or minus the square root of 3 squared minus 4 times 6 times 1 all over 2a, which is 2 times 1. You'll notice that underneath here, the discriminant gives us the square root of 9 minus 24. That's a negative number. So we're not going to get any real solutions out of that. So our only possible solution is the first one we found, x equals 2. What does that give us for the dimensions of our mold, Nate? If x equals 2, what are our dimensions? 3 feet by 2 feet by 2 feet. And you can check plugging those into your original equation. If you put in x for 2, that should give you a volume of 4. Any questions? All right.